Completing the square method is particularly useful to solve quadratic equations. There are also, in general, two other ways to solve, and that is factorization and quadratic formula. A quadratic polynomial can look like this, where coefficient of x squared is equal to 1. But sometimes it may not be that simple, such as this, where coefficient of x squared is 4. But we can make it such that it is equal to 1, just like this, inside the bracket. Let's say we make this into algebra, a general form. For example, x squared plus bx. And so how are we going to complete the square then? Well, some geometry may help us out. As you can see, there's a black square and a red rectangle here. The total area is x squared plus bx. Now we are going to cut the rectangle into half, such that this will happen. As you can see, one half is staying here, and the other half goes below the black square. As you can see, the whole shape is now a perfect square, because the lengths of both sides are equal, x plus b over 2. And so now we can find the total area, and that is x plus b over 2 times x plus b over 2. But there's this additional blue square that we do not want, and so let's just remove the area of the blue square, which is b over 2 times b over 2 equal to b squared over 4. And so there's another way of writing the total area of this shape, and this is the case. As you can see, these two are exactly equal, and this is what we call the completed square form. And so going back to our examples, and so now we can complete the square with coefficient of x squared equal to 1. And so in this case, x squared plus 6x plus 3, you're going to make it x plus 3 squared minus the square of this, 9 plus 3. And so that will give us x plus 3 squared minus 6. That is a completed square form. We have completed the square. Now let's look at this. Same thing. Inside the bracket, the coefficient of x squared is equal to 1. And so we can still complete the square within the bracket. And so that is x plus 6 over 8 squared minus the square of this, 36 over 64. Make sure that you have the bracket and add on another 3. And now we are going to expand the bracket from here to here. And so that is 4x plus, let's simplify this fraction, 3 over 4 squared minus 36 out of 16. And add on another 3. And let's simplify this fraction once more. So that's 4x plus 3 over 4 squared minus 9 over 4 plus 3. Simplify 4x plus 3 over 4 squared, and that's plus 3 over 4. And there we have it. We have completed the square. That is certainly a very interesting geometric proof. Now let's look at completing the square in a different perspective, algebraically. We will want to transform this general form into this completed square form. But how do we do that in algebraic terms? Well, let's start with this simple concept here. A plus b squared equal to a squared plus 2ab plus b squared. First of all, we want x plus something, and so we let x equal to a so that this happens. X plus b squared equal to x squared plus 2bx plus b squared. Now let's compare with this example here. X squared plus 9x plus 1. We can see that we need a certain value of b here. So let's change it so that they look about the same, like this. Now we can compare this line with this line. X squared, 2, 2, x, x. So b must be 9 over 2. And now you can see once again, we need a certain 9 over 2 squared here because there's a b squared. And so we are in a tricky position because we have no 9 over 2 squared. Well, one way to solve this problem is to essentially add 0 by adding and subtracting at the same time. Well, this is how it looks like. Red color, plus 9 over 2 squared minus 9 over 2 squared. Basically, it does nothing to the equation. And now you can see, this is all we have wanted since the beginning. We have made a x plus 9 over 2 squared. We can now group this into the square we wanted since the beginning. And now we can simplify the rest of them like that. We can simplify even more with the constants. And so as we work out to the end, we work out our final answer. X plus 9 over 2 squared minus 77 over 4. And there we have it. Two ways to look at completing the square. Here is another example, but this time the coefficient of x squared is not equal to 1, it is equal to negative 2. But in algebra, the coefficient of x squared is 1. So how are we going to eliminate that negative 2 here? So first step, we are just going to take out the negative 2 from x squared and x. Just like that. And you can see in this bracket, the coefficient of x squared is 1. So now we can complete the square just like before. We're just going to make it add 0 and just take out a 2 here. So now we can compare with x squared and x squared. That's 2x, 2x. So b is 3 over 2. And then we add 0 by adding 3 over 2 squared minus 3 over 2 squared. And then remember the close bracket and then add on the 3 here. And so here is basically this perfect square. And so we can group them together and then minus 3 over 2 squared, close bracket, plus 3. And now we are going to expand the bracket just like that. And this is 9 over 2 because this is 9 over 4. Negative 9 over 4, negative 2 times negative 9 over 4 is plus 9 over 2. And then group this together. And this is our final completed square form. And actually we can make it better in a way by putting a positive on the left hand side, negative on the right hand side.